Now the next thing to do here is basically to start configuring your board. Now in order to configure your board, you're going to obviously need to write a program that will do some configuration. Now before we clear this pin out, we had the main file here. We didn't go inside it, but that main file had some function that had some configurations of the pin, so we deleted it. Now we want to do our own one. Okay, and all the configurations you need, the settings and so forth, are all provided into the board documentation. You're going to get it from the reference manual here that basically include every single detail of this chip, this board, how to use it. And the Nucleo itself, that is your PCB, this is an electronic piece of hardware. So this one here is actually telling you what this board is made of, all the electronics components that are in the board. It will describe you everything in detail. So you also need this one. Then your schematic. So the schematic is basically the reference for the PCB layout of this board. Then you have the data sheet. Now the data sheet, you might not really need it to write the code, but if you want to know the capability of this board, you have to go into the data sheet because it tells you exactly what the board is made of. Okay, so you can see it's a 72 megahertz. That's a maximum frequency of this PCB that it is running, the CPU. So you can see all the information, and it has a 64 kilobyte of flash memory that you can actually write the code of. So all of this information, you can see the operating voltage range, 2 volt to 3.6. So if you want to know all of that, the ADC and everything, you go into the data sheet, right? But some of that information can also be found in the reference manual as you go along. So now what do you want to do? You want to configure the push button, okay, and you want to configure the LED so that they can work together. Okay, you want them to work together. So the first thing is to find where your LED is connected into the board. So if you zoom into the board, you can see that that LED that is flashing is LD2. So if you come here, you just tap LD2, right? Now it shows you where LD2 is on the schematic here on an extension connector. You can see there is a resistor 510 ohm. That is just limiting the current for it. And you've got the jumper there. Then it's even being connected to D13, right? And D13, it says that it's part of PA5. So PA5, okay? Now there is also another jumper that can pull it to PB13. But now let's go to PA5. Okay, right? We need to go into the main CPU here and see where is PA5. So this is the main CPU. Okay, PA5 is here. There is PA5, the GPIO PA5, and it is referenced as D13, right? And you also have the push button, so that the user button blue, that's B1, and it is currently being pulled up with a 4.7K resistor to VDD. That's probably your 5 volt, right? Via this SB17 jumper. So that is on PC13. So when you press it, so when I'm pressing the button here, I'm actually pulling it down via this button to ground, right? So your problem here is to configure PC13 and PA5. Now you know the information, but to configure them, you have to get hold of the reference manual as well. Now let's go ahead, write a function that we're going to do some pins configurations for our LED and push button. So I'm now going to create a function of type void GPIO underscore config. So this means this function, I will be doing my basics configuration into this function. So the function is not accepting any parameters, so I can also just pass the void in there. Okay, but now, so we know that our push button is connected to PC13 and the LED is connected to PA5. Okay, so these are peripherals, so they are GPIO. In order to use them, we have to enable the peripheral clock. So if you come into your reference manual, you type RCC. So RCC is the reset and clock control. So basically RCC register, let's look at RCC register. So the RCC register here actually provide you the clock configuration for all your peripheral. Now this is if you are writing your code just using the registers manipulation without making the use of the drivers. You're gonna have to come into the RCC register and enable the peripheral clock. But now because we are using the HAL drivers, okay, we are using the HAL drivers, so we don't have to do that. We don't have to go deep dive into the reference manual. We can just know which register to call to enable the peripheral clock. So the peripheral register, so the clock peripheral register for the HAL library drivers here can be enabled by calling the micro __ HAL _ RCC, okay, and then you press control and then hit the space key. You're going to get some option. So we want to enable the clock for port A. That is where our LED is attached. So you can hit another underscore and look for GPIO A. So these are all the options that we're getting now from GPIO A. Another underscore clock. You can now see clock enabled or disabled. Okay, so you're going to select this one and then semicolon. So this line of code provided by our library here is actually taking all the information that we would have ourselves come into the register here, select which one is GPIO A and then turn it to 1 and pass a 1 or a 0. So the HAL library is handling it for us. Okay. Now the next thing is to write some settings for our pin. So this is GPIO A. So if we come into the GPIO library file here for the HAL drivers, now if you look at it here, you're gonna have a type def struct. So there is a structure here that defines how all the pins are configured and they function. So we need to create a variable that is going to make use of this structure here. So it's a GPIO right init type def structure. So I'm going to copy that, right, and come here just under the clock and then paste it here. Okay, now I'm calling this GPIO init type def so that I can create a structure variable for my pin settings. So I can give it any name that I want to. So I'm just going to say GPIO A init, okay, like initialization, and then this is a structure, so I'm going to just leave it blank like that and always pass a semicolon. Right now, the next thing I need to do here, okay, is to now, because this GPIO A init here is now referenced into this structure, okay, and we saw that in this structure here we've got different mode for the pin. So the pin can be a pin mode, pull, speed, or alternate. So we're going to use the pin settings that we need to define here. So I'm just then going to say GPIO A underscore init. This is the name that I just gave it now, and if I hit enter, I should be getting some option here. Okay, now the options are coming, so I can see all the mode for this GPIO init type def structure. So I'm going to select the pin mode, so that is a pin mode, and then hit equal. Now this line of code is making available to us all the pins that are available on the GPIO port A. Now we know that our LED is attached on PA5s, okay, so which means it is pin 5. So if we come into this file here, we're going to basically see these are all the available pin on any GPIO. It doesn't specify any, so we can then just select the 5 here, GPIO pin 5. Again, you have to make sure which one is holding your LEDs. If your LED is on 1, you put 1, 0, you put 0, and also which port is your LED attached. That also you need to make certain of. Okay, so now we've got GPIO 5, which is a pin on the GPIO A, we've selected a pin here. Now we need to select in which mode we want to use this pin here. So if we come into these files here again, okay, we're going to see there are different modes here. We've selected a pin and there is a mode and there is a pull, there is a speed. So we need to select this pin as an output. Okay, so let's find where the mode is defined. We can see that here we've got the GPIO mode defined here. So we want to define this GPIO pin 5 as an output so that whenever we send a command, we want to send a 5 there or we want to send a 0 volt there, and whatever that is attached to it will be toggled because it is now set as an output. Now to get that mode, we're going to once again write GPIO A underscore init and then hit a full stop. Then you're going to see the mode that you need to take here. So you're going to take mode and then equal. So the mode that we want is the output here. So we're going to select the output push pull mode. So you just copy that and then you're going to paste it here. Never forget the semicolon. Now to complete the pins configuration here, we then need to take all this information that we've now declared here and pass it into the GPIO initialization function. So we've got a library handling that function for us, and that function name is HAL underscore GPIO underscore init. Now this function needs two parameters. So the one parameter is the port that you are using. So we know that we are using GPIO A. And the next parameter is the address, okay, of all the settings that we've set. So under this GPIO init def, we declare a variable GPIO init, and then we pass in the pin mode, okay, that is pin 5, and then the mode is as a output for push pull. Now we need to pass the address for that, but that address is stored into this variable here. So we can copy this variable, right, put it there, and then we have to pass the %, here to say that the address for all that setting is into this variable, and it will locate it from that statement there. Okay, now don't forget your semicolon. Right, now this is all that we need to configure that pin PA5 as an output. Now the next thing is we have to make sure that we also enable the function prototype. So let's copy this whole line and come just under here and paste it there, put a semicolon, so you can put in a comment and say function prototype. Right, so these are the function prototype, and this one here will be then your main function. Right, okay, and if you add another set comment there, you can say GPIO A configuration. Okay, we are getting close to completing the first part of this code, that is to make the LED blink, before we write the second part that will be with the button configuration. Now to complete this part, we need to first write the delay function so that the LED will blink on and off with a particular delay. Now delays can be configured using the clock configuration. If you come into your main if you come into your configuration pinout and you need to do some clock configuration here, okay, but we're not going to deal with that today here. Now let's just write a simple delay function that will basically be a counter that will count. While it's counting, it will be actually delaying our code execution. So we're going to just call a simple void function that will not be taking any parameter. So void, and the function name we can just call it delay, right? So we just call the function name delay, and this function need to be and this function will take a parameter in the form of a value, like for how long do we want to delay. So that variable need to be defined here. So we're going to define that variable as an unsigned int 32, okay, underscore t. Okay, so that's a variable type, and then we're going to call this variable as a delay val. So this is basically the delay variable or the delay value. Okay, and then inside here, since we are basically just incrementing this delay value counter, so inside the delay function here, we're going to call a for loop. We're going to make use of the for loop that will be incrementing, okay, based on the value that we're going to pass through the function. Okay, so in order to run the for loop, we also need to define another variable. So the variable name will be int 32 underscore t, and then we say I. So this is our for loop counter. Then we say for. So we can leave the for loop body blank, but then we have to start for I is equal to 0. Okay, then we need to check the condition for our for loop. I is less than the delay variable or the delay value that the user is going to pass, and then you need to increment I. Okay, then we leave the body of the for loop empty. Basically nothing will be executed, but we will be delaying based on the variable that we pass in there. So let's just copy this, okay, and then we pass it also here as a function prototype, and then we need to call this inside our while loop. So if we call this inside our while loop here, okay, so we need then to pass what? The value. So the value that we are passing here is basically a number. So you can pick and choose a number here. Let's say we want to delay in 50,000. Remember, this is going to be executing very fast, so you need a big number so that you can have a significant delay. Okay, but what are we delaying? We are delaying the LED from toggling out in a push-pull mode. So we need to call the function that is dealing with the pin toggling. So the GPIO pin toggling. Our pin here is pin 5 on GPIO port A. So that function name is HAL underscore GPIO underscore toggle pin. Then we need to pass the parameters for that function, and that function accept parameter as your GPIO port, so which is GPIO A, right? And then you need to pass the pin that you are busy toggling. So this is pin 5 on GPIO A, so we need to copy that pin. Right, so we then copy the pin for our GPIO 5. Okay, so now our program is basically ready to execute, but there's something we are missing here. As we enter the main function, we need to configure the pin configuration. So we need to copy this function so that we can call it in here. Okay, then we must remove the void because the function is not accepting any parameter. So we enter the configuration and then we start executing our while loop. So this is basically it. So we've defined the header file, okay, and then we created a configuration file, then the delay function, and then we are calling them into our main function that's got an infinite loop. So this here will be just toggling. Remember, this one here is a toggle function, so it will be toggling based on the push-pull output mode, so changing from high to low, and while also delaying with the value that we pass here. Okay, now we can then select our project here and then build. Hopefully we won't be getting any problems. Where is the build? Okay, there is build. Let's just click it there. Okay, something very important. So when you are building for the first time, make sure you click no when it asks you to generate the code, because it will generate the code configuration to the default, and your program will basically not be built. It will build a different program. So you have to say no to that, and then this next option will be asking you for building without code generation. Then you say okay, and then it will build your program with the code you just written. Okay, and then if everything is successful, as we see here, you have your button led.elf. That's your hex file, your machine code that have been created and ready to be loaded into your microcontroller. Now to load the code into our microcontroller here, so that we can first test this initial part here to see that our LED is blinking before we move into the next section, that is to configure the button. So come and select your program, the whole project, and run as. You're going to see the first configuration here. So this is a default one. Unless you've created another one, this one will be there. So you click on it, then it will pop up this window here. Then basically it tells you the project is a LED and the debug or the hex file is this one that you have here. Okay, then all you have to do is just say okay. So this will connect with your board and it will start to load your code. Okay, so let's see if it's going to load successfully and change the frequency of our LED blinking. But basically we should have a new program onto the board. Okay, so it's asking us, this version of STM provide a firmware version of the attached ST-Link. Proceed with update. So it will actually update the ST-Link, because remember this version, this board here can actually be separated, as you can see. So the small piece here is your ST-Link. So that's the programmer to program the main chip here. So what we are seeing on our screen here is actually telling us that because the STMicroelectronics we just installed a new version, it's actually include already the ST-Link updated firmware. So the one when they did this Nucleo was an old one because it's always being updated. So we just have to say yes there, so we can upgrade the ST-Link firmware version, and that will now update it. Okay, so it's bringing us the ST-Link upgrade window. So you will be getting all of this if you are running it for the first time. So just open in update mode. Okay, so then it will be opening your ST-Link. So as you can see, my debugger here is starting to blink. So the debugger button is starting to blink, and then you have to now hit the upgrade. So it will start upgrading the ST-Link. As you can see, the button on your debugger here is actually blinking. So this is now upgrading our ST-Link to a new version, that is M27. You can see the old one was 30M19. We now have a 39M27. So the upgrade is successful. Okay, we don't have to do that. The upgrade is successful. It actually just reconnected the board. So we can basically just close this window. Okay, now you can see now the debugger have turned into green. So this indicates that it have established a successful connection. So I'm assuming we have to go again, run as STM32. Okay, and then the window will appear. Okay, it's asking us to rebuild the code again. Let's rebuild. That's fine, rebuild. Okay, it's just rebuild the code again, and then let's run the configuration again, so that we can actually get the code into our board. Okay, you just need to allow it. If your firewall is blocking it, please just allow your firewall. All right, as you can see, our LED is blinking, but it seems like it's blinking exactly the same way as the previous one. But let's check. Okay, the button is not working anymore. The reset is still working, but the blue button is not working anymore. That means we have a new program here. Okay, now let's see if we can change the blinking rate here, because we have 50,000, which is causing a delay here. Now maybe let's increase it to 500,000 so that we can see if this counter is going to take slightly longer. So that will slow down our delay. It will probably start blinking slowly. So once we do that, we have to rebuild the project again. Okay, rebuild without code generation. Okay, so that's done. We have to then go again, run as, to update the code into our board. So it's going to now connect again. Once again, reboot with start generation. I'm not sure, probably there is a place to disable that so that we keep getting that that prompt. It will try to load the debugger now so that it can load the code. Okay, the debugger has been loaded. Okay, it's loading, it's loading. All right, we can see that. Okay, what's happening here now? Okay, now you can see that the blinking have changed. You can see the blinking frequency have changed because we now change 500 from 50,000 to 500. The blinking frequency have now changed. So this is basically how you run your this simple LED toggling with this STMCubeIDE. So I know this tutorial have been very long, but now I'm going to stop this here. So I'm going to do part 2. In part 2, we then going to include the code for the button, so that when we click the button, we need to change the frequency, or maybe just click the button, switch the LED off, click the button to switch the LED on. Now this is just a basic delay that we are using. So come back for part 2. Maybe if you are able to implement that code, when you press the button, the LED comes on. When you press again, the LED goes off. And let me know in the comment section if you are finding any trouble. Thanks for watching, guys. If you like this tutorial, please don't forget to give it a thumbs up and subscribe to CMTEQ channel. That would be highly appreciated. Until next time, cheers.